In today's lecture, we will discover the secrets to Waec question number 6 for the year 2024. Let's get started. Question number 6 says, an electron of mass m and charge E moves through an electric field of potential difference V0 with a speed v. Show that the de Broglie's wavelength associated with the electron is given by the expression lambda equals to h over root 2 me v0. Take the Planck constant, or take h to be the Planck constant. Okay, so before we continue, I am going to write down an expression for the kinetic energy here in terms of electron volts. So we have EV0 equals to a half mv squared. So in this expression, we are going to make the velocity the subject of the formula. So when we do that, it means we are going to first cross multiply. When we cross multiply, we will get mv squared equals to 2 EV0. I want to believe that you understand how we arrive at this point here. Look at this. If I take this to the other side of this expression across the sign of equality, then I will have 2 EV, that's 1. Or I would simply say multiply 2 to both sides of the expression. So when I do that, 2 will cancel 2 here. Okay, so when 2 cancels 2, you now see that we have 2 EV not equals to mv squared. Alright, so that's how we arrive at this point. Now, since we are making V the subject, we are looking at eliminating M at this point, and here all we need to do is to divide both sides by M. When we do that, we'll have all over M here, so that M can cancel M. That's going to be our next step, but I'm going to write it properly. So when I do that, this is what it looks like. V squared equals to 2 EV0 all over M. At this point, we have to clear the square sign so that we would be able to obtain the value of V. And at that point, it means we are going to find the square root of both sides. So when we find the square root of both sides, the square there would be eliminated. What I mean is just to put the square here and the square here so that this can cancel this, and we will be left with V. Okay, so when that is done, then we have V equals to root 2 EV0 all over M. Let's call this equation 2. So that expression represents the velocity, or I should call it the speed. Okay, but the Broglie's equation says that wavelength equals to h over p. So the h there, I have said that already. It represents the Planck constant, and then the p there represents momentum. Now that momentum, most of the times we can as well write it as mv. Okay, so in place of p, I now put mass and lambda. Mass and lambda. Let's come back here. How did we arrive at that point? Look at this. This is supposed to have been, let's say, h over mv. Are you with me? H over mv. So P here represents mv. Now, at this point, if we cross multiply, if assuming I am making V the subject, then this expression, I decide to bring lambda here and then take V out. I will have V equals to H over m lambda. Okay, so that's the expression you are seeing here. I just wanted to be a little bit faster. So that's how we got equation 3. V equals to H over m lambda. Okay, so now we are going to compare equation 3 and equation 2. When we do that, then we have H equals to m lambda equals to root 2 EV naught all over m. Okay, so at this point, we are going to now solve for the wavelength. We are going to solve for the wavelength, which is this, the de Broglie's wavelength. Alright, so everything we are going to do is to enable us get the wavelength. I'm going to remove other things one after the other mathematically. So when I clear this root sign, it will affect this in terms of square. What am I trying to say? For me to eliminate this root sign here, I have to square this, and I have to square this. Now, when I square this, this will cancel this, and of course, this square here will affect the numerator and everything in the denominator. That's what I mean. So, let's see. You now see what we get. I had to put the lambda in red so you know what we are looking for. We are solving for the lambda, the wavelength. Alright, so at this point I'm going to cross multiply. Okay, so when you cross multiply, this is how it will look like, and then I'm going to divide through by m squared 2 EV naught. When I do that, I will have a new expression. Since I'm solving for lambda, I'll now have lambda squared equals to m h squared over 2m squared EV naught. At this point, looking at this expression, I'm seeing that I have m here and 2m is here. That's why we have m squared. That is, the m here is double, so let me cancel 1. So when you do that, you'll be left with a single m at the denominator. Okay, so alright, this is a new way of writing that expression, and I am going to find the square root. Why I said square root? To eliminate the square here, I'm going to put a square root sign here that will affect both sides so that this can cancel this, and of course this square root here will also affect the numerator here and the denominator here. So I'm seeing that the root sign would also cancel the square here, so of course this will reduce. So look at how the new expression will look like when that is written. Okay, Now it will affect the numerator, so I can rewrite this as lambda equals to h over root 2m e v naught. So this is the way, how do I put it? The question said we should derive the de Broglie's wavelength. So we have been able to derive the de Broglie's wavelength, which is lambda equals to h over root 2m e v naught. Okay, so we have come to the end of this lecture. Thank you for watching, and I would like you to like our video, share it to others, and if you are watching for the first time, our homepage would be like this. Please endeavor to click on the subscribe button. When you do that, it will appear to be subscribed, so whenever I upload a new post, you can also be notified. Thank you for watching once again. Have a wonderful day. I hope to see you in our next lecture. Bye.